Welcome back to part 6, or as we also like to say, week 6 of my 2-week build. In this episode, I hope to get everything finished, but as usual, everyone has their own opinion on this. Alright, we've heard enough from you. Hello fellow CNCnutz, and welcome. In this episode, I hope to continue on and finish the build of this machine. At least the mechanical build, the bits that I need. After that, I just need to go through and do some programming. Now, if you remember last week's episode, I was complaining that this particular chain I had here was not really suitable to bring my cables up and over there. It was a bit wide and I felt it would foul on this motor here. And so I left it where I'd ordered some new chain. Here it is here. It finally arrived and now I can get it installed. This is quite a bit narrower than the previous one, and more importantly, these chain links open so that I can run my cable through here without having to remove this plug, which I really don't want to do. So while I'm doing this, I also hope to answer some of the questions you guys had. And I'll do that as I go along. Now, the first question I got was, how do I make my CNC machine play music? Well, the answer, of course, is magic. I can see this is going to be trouble. Okay, well, let's move on, and the first thing I'm going to do is I'm going to get this energy chain installed. Play something appropriate. So the first thing I need to do before I install my chain is install this here. It's just a piece of plastic that I've drilled some holes in it. Its job is as a spacer, because this here sits behind this piece here and I need the chain to go up in front. So I've made this piece here just to pack it out by about 10 millimeters so that it will just fit in there properly. Right, well, this is in place now. We can now look at the chain. Now, you've got to be careful when you do this, because you can only put this in one way round, because these pieces here that fit on the ends will go in only one end of the chain. Now, the other thing is you can't put these on first, because if you do, you end up closing up the gap and you won't be able to get your cable ends through. If, like me, it's too big to go through the gap here. So I've already unclipped these here. As you can see, it's relatively simple now just to lay my cable in like so. So I'll just clip one at the end there, one at the end there, a couple in the middle here, and hopefully that will stop any fun and games. There you go, nice and simple. And that's just going to sit up here like so. So on this end here, I've got this piece here, and it's just going to clip in here. Like that, and that there. I've got a T-nut on the end here. You can see it just there. I'll just go into one of these slots. And that's nice and secure there at that end there. Now all I'm going to do is attach this end. And for that I've got this. That just clips in here like so. Like that. And I've got 3 screw holes here. With that done, this here will just go into here like so. I can screw that down. And this here, I'm just going to wrap around like this, because this is for a future project, and I don't need it right now. Well, now's a good opportunity to see how it works going up and down. Well, that looks pretty good. I'm really happy with the way that this is behaving. Got one unclipped there. I think that's going to work really well. Now, one of the questions I've been asked is, where did I get my Z-axis from? And the answer to that is AliExpress. I just brought it off AliExpress, shipped straight out of China, and delivered to the door. It, as far as the quality of it goes, I'd rate it as being okay. They're not high-end bearings by any means. The machining looks okay on the parts, which is the piece I really couldn't be bothered spending my time doing. This here ended up a little bit crushed in the mail. There's only so much you can package an item to make it bomb-proof, and even then I think that the courier services of the world will still manage to destroy it. But even with the slight crushing effect here, it's not really a problem. It's not going to affect how this thing works. So just bear in mind, if you do want to buy one, I'll put a link on my website where I brought mine. They're not the highest quality bearings. I doubt the ball screw is actually the best you can get either. It's your basic 1605 ball screw. Okay, moving on, I think it's time to explain what these metal pieces I put on the sides here were that I mentioned last week. Now, as long-time viewers of my channel will know, I'm not really that big on the likes of homing and limit switches. However, I'm making an exception here because the controller I'm now running actually does require them. It runs just so much better, and it just doesn't work very well without them. So with that in mind, I'm adding them into this build. In fact, I'd actually already added the sensors to my previous build before I pulled it apart. So for this, I'm using these. Instead of using the mechanical switch that a lot of people use, I'm using these here. These are inductive sensors. Whenever a piece of metal, doesn't matter whether it's magnetic or not, doesn't need to be steel, it can be copper or aluminium or steel, anything of that nature, anything metallic that gets within 4 millimeters of the sensor here will trigger it and let the controller know that it's detected it. Now, most people, when they install homing switches or limit switches, what they do is they stick it here at the end of the axis, and when the axis gets close to it, it detects it, and it knows it's reached its limit or it's reached its home position. The problem is, to do that, I require a minimum of 2 switches per axis. That's a bit wasteful really, and a lot of extra wiring that I really don't need. What I'm going to do is I'm going to put the sensor here on the axis itself, and as it moves across, it will detect when it runs past this piece of metal here that it's been triggered, and will send the signal to the controller. But the beauty of this here is when it's going in the opposite direction, it'll hit the piece of metal like this here on the other side as well, and again send the signal that it's reached its limit or it's reached its home position. So that way I can make this sensor be not only my homing switch, it can also be my hard limit switch for the left and right side of my axis. That's one switch doing all 3 jobs. Okay, now with that in mind, I've had a bit of a change of heart. I now want the piece with the notch out of it on this side and this one on the other side, because I've decided I'm going to move all this down. I'm going to put the sensor on the lower run here and on this side of the axis, because I've got a plan for the other side later on. Okay, so with that in mind, it's time to make a few changes. Oh man, that music is... One of the questions I'm getting asked a bit about is about my linear rail here, and the bearings of course. So the extrusion I've used, I purchased from AliExpress, as I did the rails, and it goes by the name of an 80-160. That's 80 millimeters wide, 160 millimeters deep. It's a 2 millimeter aluminium extrusion. It's pretty hefty, and the combined weight of the rail with the bearing guides on it is 17 kg, which is fairly heavy. I don't see it bending anytime soon, but even so, there are some dents on it. This corner's been dinged in a bit. It's been closed up just a little bit at the very end here, and that again is because even a hefty rail like this is no match for the courier services of the world. It was well packaged, it was wrapped in cardboard, lots of plastic and bubble wrap, but even so, you just can't expect miracles. That said, it's still nice and straight and perfectly good for this job. These rails here arrived in perfect condition, and they are 20 millimeter linear bearings. They're all 1200 millimeters long. Now, I don't know how good the quality of the bearings actually are. They did feel like they had a little bit of hesitation in it. I gave them a bit of wash out, and then I re-greased them, and I put grease into them. Like I said, I don't know much about them. I'm sort of learning as I go. Okay, so another question I get asked is about the spindle. So this is a 2.2 kilowatt spindle, the same as my previous one. And this one here is from G Penny. It sounded like a pretty good spindle. Again, AliExpress. And I'll put a link to all of these things I purchased on my website. They're not affiliated links. I don't get anything for them. But hopefully, if you're looking for something, they may be what you want. I'm not endorsing them in either. I'm not saying they're good or bad. I don't know. I haven't tried them. This just happens to be what I purchased for my setup. This spindle actually has ceramic bearings. I went for ceramic ones this time rather than steel bearings. Okay, so next I need to fit these homing switches, and I've already made the aluminium mounts for them, so they should just go into place and connect. So the first thing I put in place is this piece of angle aluminium. It's sitting on the linear bearing here, so that when it goes past this sensor here, it'll be detected. And this sensor is going to sit down around about here. Unfortunately, it can't go any higher because this chain here is in the way. But that doesn't matter. There's plenty of movement on this here, so it's going to work out good. And here I've got two connectors. I've already put plugs on them, so this here will just simply plug in like so. And as you can see, when it's come up here, this red LED has come on, and that's because it's detecting the metal. The second sensor is this one here, and this one is going to go down the bottom here. So now that I've got my sensors in place, I've got a small problem, and it's to do with these cables. How do I deal with these here? Because I can't simply cable tie them to the side of my rails here. I need some way of holding these in place so that they don't end up snarling up on anything else. Ideally, I'd like them to remain inside these channels here. But how am I going to do that? And it's not just these cables as well. It's also my stepper motor drive cables and anything else that isn't contained within the energy chain here that I need to deal with. So I was looking through my local store and I came up with this here. It's described as an Energy Seal quality EDM rubber, whatever that is, and it says EDM sponge. So it's not a solid rubber. It has got a little bit of give in it. It is a little bit spongy, though it's not overly soft. And this is a 9mm cross-sectional area. And I'm going to be using this to hold all the cables I need to in place. Let me show you how. So here's my wire here. I'm just going to put it into the slot. I'm going to do the same with this one here. And then I'm going to take my piece of rubber and I'm just going to push it into the slot like so. And this here should seal it in place and keep it out of harm's way. So that should keep it nicely sealed out of the way. And then I'll decide what to do with this little bit of slack here that's left over. That won't be a major problem to get rid of. Now I've done the same for these wires here. This is the wire for my stepper motor, and I can just push the bit of rubber into the slot here. And the same for this one here. This is another sensor that I've put on my Y-axis, and it just come up here. It's got the rubber pushed into the slot there, and then it just makes its way over the top and into here. So this rubber is going to keep my wires in place, and it doesn't come out easily. This wire just won't pull out very easily at all. So I think that's going to solve the problem of these wires here moving around on me. So while I might not be able to help you with where you can get this rubber O-ring material from, I can tell you a little bit about the specs of the machine, or at least the weight changes that have come with this upgrade. So the original XZ carriage with its rail weighed 24 kg. Add to that the spindle, another 5 kg. That comes to a total of 29 kg for the old XZ rail and carriages. The new one comes to a grand total of 42 kg, including the new spindle. The new spindle is a little bit heavier than the old one. So that makes me somewhat glad I did upgrade these motors, though I probably would have got away with the old ones as well. Nonetheless, since I'm going to all this trouble, I might as well do it once and do it right. Now, I have lost some movement on the table. This carriage is slightly forward more than the previous one. That's because I put this rail on the front of the carriages and not on the rear like on the previous design. That means I've lost about 60 millimeters of table at the rear of the machine that I will no longer be able to use. Now I don't want to it comes further forward a lot more than the old one, of course, to make up for that, but I don't want to add any more to the front of the table, so I'm just going to live with that loss at the rear. I may change that at a later date, but in the meantime I'm just going to live with the slightly shorter table. It's not going to make a huge difference. So that's going to make my table about 950 millimeters long instead of 1 meter long as it was before. And that's where I'm going to leave this episode, because there's still a lot more to do. I may now have the mechanicals all in place along with my homing switches, motors and everything else, but there's still more to do. The table needs to be flattened. I need to make sure that it's trammed properly. I then need to be able to set up the squaring on it to make sure it's square. I need to double check that the distance moved by each motor is correct. I've got no doubt that the X and Y will be perfectly fine, but the Z is an unknown quantity. I haven't looked at that yet. So all that remains me to do is to thank you guys for watching, and I'll catch you on the next one. Cheers.